This is a question about finding the equation of a conic that passes through some points. And this one has 5 points: 3/4, 9/4, 1, 1, 19/12, 3/4, 9/4, 3/4, 33/5, and 9/5. And it says set the a value equal to 1. Well, the general equation is, this is called the general form of the equation, ax squared plus bxy. This xy term is a rotation, plus cy squared plus dx plus ey plus f equals 0. And so these, to see it with a rotation, to determine if it's a circle, ellipse, parabola, or hyperbola, is not the same as determining it when there isn't a rotation. Well, anyway, so I'm going to plug these points into this general equation, and I'm going to use this one with a set to 1, and then find 5 equations. Put those into matrices, into 2 different matrices, and then use the inverse of the first one equals, or times, the matrix. It's going to be a 1 by 5 matrix with the solutions, or with the equals whatever, with the solutions of each one of these 5 equations, and then I'll get my value for B, C, D, E, and F. So here's the first point, is 3/4, 9/4. Remember, it's x squared, 3/4 squared, plus xy times b. So 3/4 times 9/4 times b, plus y squared times c, 9/4 squared, plus x times d, 3/4 times d, plus y times e, 9/4 times e, plus f equals 0. And then I do all those calculations, and I subtract 9/16 from both sides because I want this to be an equation. I want it to have an answer on the right side, a solution. And then I get a bunch of fractions. I'm going to multiply by the least common denominator, in this case 16, to clear the fractions. Easier to deal with whole numbers. And so there's equation 1. 27, 81, 12, 36, 16, and then -9. So in my matrix, this is going to be a 5 by 5. I'll put these 5 numbers in the first matrix, and I'm going to take the inverse of that one, and I put -9. And this is going to be a 1 by 5. There's going to be 4 more positions for each one of my other equations. 2, I use the point for 2. The point is 1, 1. Well, this one comes out very nice and easy. 1 squared plus 1b, 1 squared is 1, plus 1b, plus 1c, plus 1d, plus 1e, plus 1f is 0. I subtract the 1 from both sides, and it's b plus c plus d plus e plus f equals -1. So in the matrix, I'm going to enter 1, 1, 1, 1, 1, and then in the 1 by 5, -1. And I'll do this in a second. Oh, I think I'm going to have to do it. I had already set it up, and then I think I closed the window, and I didn't mean to do that. Here's the next point, 19/12. Let me try to get that closer to the center of the screen. And so then I do all the math on that one, and it ends up 19/12 squared plus 19/12 times 3/4 b plus 3/4 squared c, which is y squared, plus xd, which is 19/12 d, plus 3/4 c, plus f equals 0. I find out what all those numbers are. Probably use a calculator, or you can do it by hand if you want. I'm going to subtract 361 over 1/44 from both sides, and now multiply everything by 144, and I get this for equation 3. That's what I'm going to put into the matrix. You can do it on a TI-84. I'm going to do it on Desmos. Then I've got 9/4 and 3/4. I put x squared, which is 9/4 squared, and then xy, y squared, x, y, and then plus f equals 0. I'm going to subtract that 81/16, which is x squared, 9/4 squared, from both sides. Then, of course, multiply everything else by the common denominator 16. And here's equation 4. And then here's equation 5. Here's equation 5. Well, I guess I've already gotten the answer from Desmos, so I'm not going to do it during the video. But here's what I get for equation 5. 33/5 squared is 1,089 over 25. That's going to end up on the right side because I'll subtract it from both sides. X times y is 297 over 25. Y squared is 81 over 25. X is 33/5, Y is 9/5, and then plus 1F. And then I multiply everything by 25 and end up with this: 297, 81, 165, 45, 25, 108, negative 1089. So now I will use those. I will enter that as the matrix. The A matrix is all of these numbers for each equation. Then I will take the inverse of that and multiply it times the B matrix, which is just the solutions. Negative 9. I think the second one was negative 1. Negative 361. Negative 81. And then negative 1089. And when I do that, when I enter that, these are the answers it spits out for me. Remember, I have to I'm putting the A. So it's ax squared, and A is just 1. It gives me, these are the answers from the matrix. A is just 1. I remember that from the start. So I put in negative 10/3. Well, okay, I'll do it. They're demanding. I'm hearing demands that I do this. So let me try to pull up Desmos if this won't. Why won't that shut down? All right, I'm going to go to Desmos. I'm going to do it in Desmos. Matrices. Okay. And you can do it on your TI. I'm going to put, oh, wait a minute. I'm going to put a new matrix. It's going to be a 5 by 5. And I'll put these numbers. I've got the first one is 27, 81, 12. 27, 81, 12. 36, 16. I'll make the other matrix later that have all the solutions in them. Here's the second one is just 1s, and for some reason I put 2s. And then the third matrix is 171, 81, 228, 108, and 144. Third one is 27, 9, 36, 27, 9, 36, 12, 16, and then the fifth one is 297, 81, 165, 45, 25. Then I have to make a new matrix. This one's going to be a matrix B. It's 1 row, 5 columns. Wait a minute. 5 rows, 1 column. Yes, that's what I want it to look like. And I put the answers in there. The solutions, which is, where's the first one? Negative 9. This one was negative 1. I remember that. Number 3 is negative 361. Matrix 4 is negative 81. And then this one, man, this is a big number. Number 5, if I can find it down here, it's negative 1089. And now I'm going to take, where's my matrix equations here? Something is amiss. Oh, there it is. Okay, I had to hit enter. Okay, then I take matrix A and the inverse of it times matrix B, and I turn those into fractions. Now remember, A is 1, and that's where I get these. So it's A was 1, and these come out of the matrix solution. Negative 10/3, 1, negative 4/3, negative 4/3, 4. And then I multiply everything by 3. 3 times 1 is 3. 3 times negative 10/3 is negative 10. 3 times 1 is 3. 3 times negative 4/3 is negative 4. 3 times negative 4/3 is negative 4. And 3 times 4 is 12. Now, how do I know if this is an ellipse, a hyperbola, a parabola, a circle? Well, there's something just like with a quadratic. There's the discriminant, b squared minus 4ac. Remember, what's in front of x squared is a, what's in front of xy is b, what's in front of y squared is c. So b squared is negative 10 squared is 100, minus 4 times 3 is 12, and c is also 3 times 3 is 36, so minus 36 is 64. If the discriminant is positive, the conic is a hyperbola. If the discriminant equals 0, it's a parabola. If it's less than 0, and A is equal to C and B is equal to 0, it's a circle. If it's less than 0 and either A doesn't equal C or B doesn't equal 0, then it's an ellipse. But in this case, it was positive, so that makes it a hyperbola. But anyway, that's how to work this kind of a question. You just have to set up the matrices and then use a calculator to find what the solution is to that system of equations. 5 equations, 5 unknowns. Pretty easy when you do matrices. Oh, and I might as well, I was going to stop recording, but let's show what it looks like here. 3x squared minus 10xy plus 3y squared, and I think it was minus 4x minus 4y plus 12 equals 0. And in fact, just as the discriminant showed, it is a hyperbola. And because that xy term wasn't 0, there was an xy term, this thing is rotated. And that's it. Now, you think, can you figure that out using just the points that were given? Well, let me try. I've got 3/4, 9/4, whoops. That'll be 1 point. And then I'm going to put in the next point, 1, 1, and put in the next point, 19/12, 3/4. Now that's a point. Is this 9/4, 3/4? Do you think you're going to be able to tell that this is an ellipse? And then the last one was 33/5 and 9/5. I don't know. I don't know if you're going to be able to tell. Well, it looks like those are all at the top part of the ellipse. Let me put the ellipse in again. So I don't know. Maybe you'd be able to tell. This was... I'm just trying to see if I could tell if this was an ellipse. 3x squared minus 10xy plus 3y squared minus 4x minus 4y plus 12 equals 0. Yeah, well, see, it only gave one arm of the ellipse, so I don't think you'd be able to really tell the whole thing. You wouldn't get any information. Well, did it give some information about that? What's that? No, I don't think so. All these points are up there. So I don't think you'd really be able to draw the ellipse just by looking at the points. I think you might know you might think it's a parabola because you've got only those points up there. 1, 2, 3, 4, 5. So yeah, you might think it's a parabola at that point if you just plot the point. So you have to go through this whole rigmarole, but that's it.